That is totally not that paper. What is going on? A difference in resting. Oh, it's higher. So like the null would be like equal to something. Okay, what is it? I'm giving up. Okay, so that is going to be important. Is the what? The number of quarters between these two, not really between those two, but between the averages. That's going to be important because if this was 117.6 and this one was 117.3, then probably what? Then probably there's no difference between them, right? It was just this sample that we took and it happened to be a little bit bigger. That is important, but we know that the sample was bigger. We want to know if what are we trying to prove? We know the boys in this sample can do more push-ups than girls in that sample. What we're trying to talk about is boys and girls in the entire population. So we want to know if the mean number of quarters that the bounty can hold is what? Higher than the generic. But wait a second. Is that the null or the alternate? That's the alternate. What we want to try to prove is that the bounty is higher than the generic. So what's the null? That they're equal to each other. What? Now, we have two different what? Two different mu's. Why do we have two different mu's? Because we got the mean push-ups for the boys and the mean push-ups for the girls. All right? So we got the mean for the bounty and the mean for the generic, and those two are independent of each other. Now, what are we trying to prove? The bounty thing is greater than the generic. The mean for the bounty is greater than the mean for the generic. Oh, there it is. Wonder if it's been recording this whole time. Oh my goodness, it has been. Oh, yeah. I figured out that it's easy to record these lessons, so I started recording them, but I haven't perfected the whole system. But I did figure out that if I walk away and start talking, you can't hear me. And then when have you heard me talk already? Man, I'm loud. Okay, so.
I can set up a tripod and a camera in here and they'll just record you during the lesson.
Oh, that's a good idea. Well, the good news is once I record on here, I just go boop and I pop it right into Google Classroom, and you go watch these guys over and over. That would be fun.
Wait, when did you start?
Like Anderson used to record his lessons, and he made like a YouTube channel. I feel like everyone.
Okay, now what has to be true? The two samples have to be independent of each other. By the way, does anybody know what this is called? Is it a paired t-test? Are we pairing anything together? We're not pairing anything. It's two samples. It's called a two-sample t-test.
Oh, yeah.
Oh, yeah, because it's on the top of the page. Look at that. Two-sample t-test. The two samples are independent because the bounty and the generic are completely independent of each other. They need to be random samples from each of the populations. And they need to be approximately normal unless they are large samples. In this case, they are because they were bigger than 30. So I didn't even need to look at it, but the generic and the bounty seem to be pretty normal anyway. by the way, this stuff, checking these conditions, in the RStudio part, the other part, stating the hypotheses, these guys are all in the other problem set. All right, so now we need to find a t-score. Oh dear. Okay, how many means do we have? 2. How many standard deviations do we have? 2. Okay, so now we got a problem here in that my formula sheet tells me, hey, you could do this no problem. You just take the mean difference, subtract 0, divide by the standard error. Well, we have 2 means, 2 standard deviations. So what do? We look up at the top of the page and we say, oh, wait, look, here's another formula. Now, this guy looks a little bit different because we have 2 sample means, but we also have 2, what are these guys? Population means, right. Now, what should this part always equal? Why should they always equal 0? That's what we're assuming. We're assuming they are the same, which means that they are, they're the same. So the difference is 0. So this guy right here will always be 0. Now this guy won't always be 0. But the bigger that difference is, the more significant it is. So what is, I'm going to write that all down here. X bar 1 minus X bar 2. And I'm just going to do this, minus 0. Because 98% of the time, that's going to be 0 right there. There are some weird problems. I don't think you'll ever have one. But it says, hey, we know bounty is better, and that's okay because it costs more. We want to know if it's 3 times better. We'll hold 3 times as many quarters as the generic. And then we put that value in here instead to see if it's bigger than that difference. But for you guys, 0 is usually it. All right, over square root of. So my standard error is what? S squared 1 over N1 plus S squared 2 over N2. So you just have to take into account both standard deviations and both means. So I'm probably going to write this about 1 time. So the top would be what's the difference between your means? 17.6 minus 8.1 minus 0. So 6.64 squared over 30. Now, we will always ask you, what's the standard error? So you always got to do these guys in parts. What's the confused look for? Did I write something wrong? All right, 29.5 on the top. Standard error is?
Is it the standard error the whole big thing underneath there?
I'm sorry, say that again.
The standard error is like everything in that big square root?
The bottom is the standard error, the whole thing underneath the square root.
Alright, cool.
Yeah, just like it was on this part, it's S over the square root of n, except we have to do what first to it? Before we can add those 2 standard deviations, we have to square them first and then square root them. So what is that bottom part? $1.67. So are we going to find a difference here? Well, sure, we're going to find a difference. If the standard error is 1.67 and the difference between our two means was 29.5, I got 17.67 or 66, either way. So is there a difference between those? Oh yeah, there is. So what is that p-value? Do we even need to look it up? It's basically, well, it's less than what? It's less than 0.5 for sure. Right? And if I go to, how many degrees of freedom? Oh, good question.
Please pardon the interruption. This is a reminder that there will be no wind tutorials today.
Yeah,
When the
you
bell
suck.
rings, students are to go to 6th period.
I'm so mad.
By the way, on the video, that was Allie, just in case you want to know.
Are you actually gonna post that?
Oh, yeah, I am.
I'm like, now I can like watch what you
Well,
say.
8 years,
Yeah, I have to watch what you say.
8 years from now, when somebody's watching this video, they'll be like,
Sorry.
wonder who Allie was. Why she use
Yeah,
that?
we talked about
Why
it.
she use that kind of language? Okay, so how do we determine degrees of freedom?
So whatever we want.
All right, there is a, oh my goodness. I totally had this, my book changed. Now I can't find the formula. And I have it almost memorized.
No.
I almost had it memorized, but I keep forgetting one part of it. So go ahead and copy the formula down to calculate standard deviation. Just kidding, just kidding, just kidding, just kidding. We're not going to use this formula.
Why would you get out of here?
Just, what?
What?
Okay, we're going to use the smaller of the two.
That's what I said. Why didn't you go with me first?
Smaller in,
You can do it.
minus one.
Take off your nice ring.
now, good news is the conclusion is what? It's smaller than 0.5, so we're going to reject the null hypothesis because the p-value is less than 0.5. Say that there was a difference between Bounty paper towels and generic paper towels. Oh, man. All right. Have a good weekend. May stop.